Hi students, today part B solved problems. Topic 8 is very short questions. What is the first question? In very short questions, insert 4 rational numbers between 3 by 4 and 1 with and without. With and without using a plus b by 2 formula. What is a plus b by 2 formula? It is an average. If a, b are rational numbers, how to insert a rational numbers between a and b? You have to take average. A plus b by 2. Insert rational numbers between 2 and 3. What you have to do? You have to take the average of 2 and 3. 2 plus 3 by 2 is equal to 5 by 2 is nothing but 2.5. What is the rational numbers between 2 and 3? 2.5. Means 2.5 means that is 5 by 2. As 2.5 is greater than 2 and less than 3. If you want to insert another rational numbers between 2 and 2.5 means you have to take average of 2 and 2.5. Say this is 4.5 by 2. 2 2s are 4. 2 2s are 4. 10. 2 5s are 10. What is the rational number between 2 and 2.5? That is 2.25. These are rational numbers. Rational numbers are real numbers. Rational and irrational numbers are nothing but real numbers. We have to insert a rational number between 3 by 4 and 1. How many rational numbers we have to insert? 4. What do I have to do? I have to take the average of 3 by 4 and 1 using a plus b by 2 formula. See what is a here? 3 by 4 plus 1 by 2. By 2 means 2 by 1. It is easy for you if you take 2 by 1. You have to take, what is the LCM here? 4. 3 plus 4 ones are 4 by 2 by 1. It can be written as 7 by 4 by 2 by 1. And this is equal to 7 by 4 into 1 by 2. 7 by 4 2s are 8. The rational number between 3 by 4 and 1 is 7 by 8. And we have to insert 4 rational numbers. Again what I have to do? I have to take the average of these two. And you have to take average of these two. You will get a rational number between 3 by 4 and 7 by 8. Again, 3 by 4 plus 7 by 8 by 2. You have to take the average. What is the LCM of 4 and 8? 8. 4 2s are. We have to multiply it with 2. 3 2s are 6 plus 8 1s are. We have to multiply with 1. 7 1s are 7 by 2 by 1. Next, 13 by 8, 13 by 8, directly I am writing 2 by 1 can be written as 1 by 2. 13 by 8 2s are 60. What is the rational number between 3 by 4 and 7 by 8? That is 13 by 60. We will write another rational number between 7 by 8 and 1. 7 by 8 and 1. What? We have to take the average. Average means using a plus b by 2 formula. Say, what is the LCM? 8. 7 plus 8 by 2 means 2 by 1. This can be written as 7 plus 8, 15. 15 by 8 into 1 by 2. 15 by 8 to the 16. What is the rational number between 7 by 8 and 1? That is 15 by 16. How many rational numbers are over? 1, 2, 3. We have to find another rational number between 7 by 8 and 15 by 16. 7 by 8, you take here 7 by 8 plus 15 by 16 by, you have to take a plus b by 2 formula by 2. 2 means 2 by 1 ut. 16. What is the LCM? 16 is the LCM. and you have to multiply with 2. 14 plus 16 ones are means you have to multiply with 15 by 2 by 1. What is the 14 plus 15? 29. 29 by 16 into, I am writing 1 by 2. 29 by 32. 16 to the 32. Like that, here, what is the rational number between 7 by 8 and 15 by 16? That is 29 by 32. I have inserted 4 rational number between 3 by 4 and 1. 13 by 16, 7 by 8, 29 by 32 and 15 by 16 are rational numbers between 3 by 4 and 1. Hi students, I have inserted 4 rational numbers between 3 by 4 and 1 with using a plus b by 2 formula. Now we have to insert 4 rational numbers between 3 by 4 and 1 without using a plus b by 2 formula. It is very easy, you see. 3 by 4 and 1. First, what is 3 by 4? What is the meaning of 3 by 4? You divide 3 with 4. 0.30 means 4 sevens are 28 to 20. 4 fives are 20. Means 3 by 4 0.75. 0.75 is a rational number. Like that 0.75. It is 1. Very easily we can insert 4 rational numbers between 0.75 and 1. Infinite rational numbers we can write. I will write just 0.76, 0.77, 0.78 and 0.79. These are 4 rational numbers between 3 by 4 and 1. We can write infinite rational numbers between 0.75 and 1. We can write infinite rational numbers between these two also. 0.75, 0.751, 0.752, 0.753, 0.754. Like that we can insert many rational numbers between 0.75 and 0.76. There are infinite rational numbers between 3 by 4 and 1. Hi students, what is the second problem? Insert 4 irrational numbers between 4 and 5. Rational numbers means it is in the form of p by q. Q is not equal to 0. Irrational number means root 2, root 3, root 5, root 6, root 7, root 8, root 9 is not an irrational number. It is a rational number because root 9 is equal to plus or minus 3. You see, you take 4. What is the solution? See, you take 4 can be written as, what is 4 square? 4 square is 16. Means 4 square is 16. Root 16 is equal to 4 plus or minus 4. You take root 16 is equal to plus 4 you take. You can take anything. Root 16. What is the 5 square? You take 5. 5 square means 25. Root 25 is equal to plus or minus 5. Root 25 is equal to 5. Plus or minus 5 or 5. Root 16 is not an irrational number. We have to write irrational numbers between root 16 and root 25. See, root 16 is not an irrational number. It is a rational number because root 16 is equal to plus or minus 4. If you take plus 4, it can be written as 4 by 1. If you take minus 4 also, it can be written as minus 4 by 1. It is a rational number. It is in the form of p by q and q is not equal to 0. P, q are integers. Okay. But you take root 17. Root 17 is an irrational number. Root 18 is an irrational number because it can be written as 9 into 2. Root 9 means 3 plus or minus 3 root 2. Root 2 is there. That's why it is an irrational number. Root 18 root 19, root 20, root 20, root 21, root 22, root 23, all root 20, all you can write. How many we have to insert? 4 irrational numbers. Root 17, root 18, root 19, root 20. Many irrational numbers we can write between root 16 and root 25. Like this, we have to do. Irrational numbers between 4 and 5 are root 17, root 18, root 19, root 20. Like this, you have to do. Now, what is the third problem in very short questions? Check whether 8 by 625 is terminating or non-terminating decimal expansion. For terminating, denominator should be in the form of 2 to the power of n into 5 to the power of m n or non-negative integers. See, if it is terminating, denominator should be in the form of 2 to the power of n into 5 to the power of mn are non-negative integers, or 5 to the power of m into 2 to the power of n. It can be written as 5 to the power of m into 2 to the power of n. Anything you can write. You see, you take, what is the solution you have? You take 8 by 625. 8 by. We will do prime factorization. Prime factorization. We have to do prime factorization of 625 denominator. See, 625. You take 5. 5 ones are 5 2s are 10. 5 5s are 25. Next, 5 2s are 10. You will have 2 25. 5 5s are 25. As this can be written as 5 5s are 25. See, 625 is equal to 5 to the power of 4. 625 can be written as 5 to the power of 4. You write 5 to the power of 4. Denominator should be in the form of 5 to the power of m into 2 to the power of n. So you have to divide and multiply with 2 to the power of 4, so that it is very easy to do multiplication and division. 8 into 2 to the power of 4 means 2 into 2 into 2 means 16 by 5 to the 10. It can be written as 5 into 2 whole to the power of 4. 16 8s are 128 and 5 to the 10, 10 to the power of 4. It can be written as 128 by 10,000. 1 2 3 4 4. It can be written as 0 1 2 3 4 should be there. 0 1 2 8. As it is 8 by 625 is terminating decimal expansion. Denominator is 5 to the power of 4 into 2 to the power of 4. That's why denominator is in the form of 5 to the power of m into 2 to the power of n, where m and n are non-negative integers. Therefore, 8 by 625 is terminating decimal expansion. What is our fourth problem? Is 51 by 75 non-terminating repeating decimal expansion? Justify your answer. What is given here? 51 by 75. For terminating decimal expansion, denominator should be in the form of 5 to the power of m into 2 to the power of n. mn are non-negative integers. We will check whether the denominator can be written in the form of 5 to the power of m into 2 to the power of n. See, you take prime factorization. Prime factorizing denominator, that is 75. 75 you take, it can be written as 5 ones are 5, 2, 5 5s are 25, as 5 3s are 50. See, denominator 51 by 75 can be written as 5 square into 3. 3 is present in the denominator. We cannot write denominator in the form of 5 to the power of m into 2 to the power of n. That's why it is not terminating decimal. Therefore, it is non-terminating repeating decimal expansion or recurring, because denominator cannot be written in the form of 5 to the power of m into 2 to the power of n, where mn are non-negative integers. Therefore, 51 by 75 is non-terminating repeating decimal expansion. Hi students, now fifth problem. Check whether 6 to the power of n can end with digit 0 for any natural number n. Natural number means any positive integer. Any positive integer ending with 0 should be divisible by 5. Any positive integer means natural numbers. Any positive integer you see, any positive integer ending with 0 is divisible by 5. What is given? 6 to the power of n. N is a positive integer. You take 6. 2 3s are 6. It can be written as 2 into 3 whole to the power of n. N belongs to natural number. It's a positive integer. 6 to the power of n does not have 5 as a factor. It should be divisible by 5. It is not contain 5 as factor. 6 to the power of n does not end with 0 because it is not having 5 as factor. It cannot be divisible by 5. 6 to the power of n does not contain 5 as factor. It cannot be divisible by 5. Therefore, 6 to the power of n does not end with 0. For any natural number n. I will show with example. You take 6 to the power of n. N is equal to 1, you take. N is a natural number, n is equal to 1, you take. 6 to the power of 1, 6. N is equal to 2, you take. 6 to the power of 2, that is 36. It is not ending with 0. 6 to the power of 1, 6 to the power of 2, 6 to the power of 3. Say you take n is equal to 3. 6 cube means 6 into 6 into 6 means 36 into 6, 216. If you see these digits, they are not ending with 0. That's why 6 to the power of n does not end with 0 for any natural number n. What is our sixth problem? Prove that 3 plus 2 root 5 is irrational. It is irrational, we know, because root 5 is there. We know this is irrational, but we have to prove. By indirect proof, we have to prove this is irrational. Let us assume this is a rational number. Let us assume. Let us assume to the contrary. Three plus 2 root 5 is rational. See, this is irrational, but let us assume to the contrary 3 plus 2 root 5 is rational. 3 plus 2 root 5 is equal to a by b. It is a rational number. A by b is a rational number. Let us assume this is a rational number. A, B are co-primes. A, B are co-primes. Co-primes means they will have one as a factor. Rearranging the equation, 2 root 5 is equal to a by b minus 3. 2 root 5 is equal to, take LCM, this is b and a minus 3b. This can be written as 2b. Root 5 is equal to a minus 3b by 2b. We know this is irrational. Root 2, root 3, root 5, root 6, root 7, these are all irrational numbers. We know root 5 is irrational number. And this is a rational number. You see, this is irrational, we know, but this is rational. Irrational cannot be equal to rational. This is contradiction. This is contradiction. Our assumption is false. Therefore, 3 plus 2 root 5 is irrational. So, 3 plus 2 root 5 is an irrational number. I want to tell one thing to you. You will have a doubt how a minus 3b by 2b is a rational number. You see, I will tell you a minus 3b by 2b is rational. Is rational. How? You see, you take a, what are a, b? A and b are integers. They are co-primes. You take a is equal to 2 and b is equal to 3. Substitute the values of a is equal to 2 and b is equal to 3 in this one. You will get a rational number. See, a is equal to 2. 2 minus 9 minus 7 by 6. You are getting minus 7 by 6. Minus 7 by 6 is a rational. You see, this is irrational and this is rational. This is a contradiction. Our assumption is false. Therefore, 3 plus 2 root 5 is an irrational number. Please correct the spelling of assumption.